Alright, so three different forms we're going to be dealing with. The first one we were looking at is vertex form. We call it completing the square form because we're going to do that later on. But if you notice, if it's with the x, it moves it left and right. And I say opposite of how we think. And this is actually, if it's with the y, it's moving it opposite as well. Now, where that changes is usually we're used to seeing it like this, and so it's left and right with the h, opposite of what we think. So if it's plus 3, it moves it to the left. If it's minus 3, it moves it to the right. And if it's plus k, that moves it up and down exactly how we think. So if it's plus 3, it moves it up. If it's minus 3, it moves it down. Okay, so no need to memorize. If it's with the x, it moves it left and right because the x deals left and right. If it's not with the x, it must be moving it up and down. And so, and then the a might flip it. If negative, it flips. Otherwise, it's a vertical stretch. Or a shrink. Now, if it's bigger than 1, it's a stretch. If it's less than 1, it's a shrink, and that's what we were dealing with. If that was a 2, it would double all the changes and it would be taller. If it was 1/2, it'd shrink all the changes. It'd be smaller. So vertex is HK, and I don't memorize this form. I memorize sort of the when I see it in the specific kind. And x equals h is the axis of symmetry because it goes right through the x coordinate of the vertex every single time. I'll show you what I mean. So, analyzing this. Negative out front. Flip. So it goes upside down. Minus 2, what we talked about with the x is it moves the opposite because you have to plug in a positive 2 to get it to 0. So that moves it to the right. And it moves it up 9 because after you move it, you add 9 to everything, so it's going to add 9 exactly how we think about it. Opposite for the x, not opposite for the y, as long as it's not with the y. So to the right 2, up 9. That is our vertex. Our axis of symmetry is going to go right through that point. It's going to be x equals 2, because vertical line, all the x's are 2's. And then it's going to go down, so 1 squared is 1. Left and right 2, 2 squared is 2, 3, 2, 4. And 3 squared, 1, 2, 3. 3 squared is 9. And again, you could go to 4 squared. We can deal with it. So, a few things we can see. X-intercepts. That's when the y value equals 0. So let's plug in 0 for y. 0 equals negative x minus 2 plus 9. If you subtract 9, it's very tempting to multiply this out right here. It's a lot easier if you don't. Let's divide by the negative, x minus 2 squared. And then what we're going to do is take the square root of both sides. When we do that, you have to remember when you take the square root to add the plus or the minus, because 3 squared can be 9 or negative 3 squared can be 9. So plus or minus 3 is equal to x minus 2. So x minus 2 equals 3, or x minus 2 equals negative 3. So x equals 5, and that makes sense because that's what we got there. And x equals negative 1. And that's what we got there. So 5, 0, and negative 1, 0. The y-intercept, that's when you haven't gone left or right, so that's when the x equals 0. So y equals negative 0 minus 2 is, we'll just do this because this is a common mistake that happens. Negative and this negative, it's very tempting to cancel that out, but exponents come before multiplication. So that's negative 4 plus 9. So y equals 5. And again, and that's what we got right there. Anyways, you can do it algebraically, we did it graphically, but we're going to have to do it algebraically sometimes because it's not going to be as pretty all the time. Domain. Again, the domain is going to be all real numbers because we can plug anything in there. We can square anything we want, all of that. The range, all of our y values go down here. It's going to keep going down, but it's never going to get above our vertex. That's our maximum. So y values are less than or equal to our 9. And that's that. So that is vertex form. It's very nice because you can find your vertex very, very quickly. Let's multiply this out, and if we multiply it out, we get what we call general form. And this is probably what you're used to, ax squared plus bx plus c. You use it for the quadratic formula, things like that. When you multiply this out, you have to be very careful with this squared. That squared does not get distributed into that. You have to multiply it out as x minus 2 minus x plus 2. So here's what I mean. This is not equal to x squared minus 4, or even plus 4 if you think about changing the negative. So that's a big no-no. One of the most common errors, try to ignore it. You cannot distribute squares over subtraction or addition, and that's the problem with it. So instead, multiply it out, x minus 2 times x minus 2. So you get x squared minus 2x minus 2x, so that's a minus 4x. Outside inside term is the 4x, and then plus 4. So distributive property, right? And then negative x squared plus 4x minus 4, distribute, 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 plus 9. So y equals negative x squared plus 4x, and then we group these two together, we get plus 5. How do you find the vertex in general form? Well, because it's not always easy to convert back to the other form, back to this, because you have to complete the square. You have to use these a's and b's. The axis of symmetry is x equals negative b over 2a. So in this case, x equals negative 4 over 2 times, so the 4 is the b, so negative 4. The a in this case, there's that 1 out in front, but it's negative 1, so like that. So negative 4 divided by negative 2 is positive 2. So that's the x-coordinate for the vertex. Plug in x to find y. So, negative 2 squared plus 4 times 2 plus 5. So that's negative 4 plus 8, so that's 4 plus 5 equals 9. So the vertex 2, 9. And that's what we had before. So the key here is to find the axis of symmetry first, negative b over 2a.